Okay, so this is one of the more intermediate questions using trigonometry to apply for integrations and finding exact values. And this might as well be like one of the huge questions with part A, B, and C. And then this might be 13 marks. And the target obviously is to finish this question in like at most half an hour, because anything longer than that, well, you'd have no time on your exams. So part A is the easiest. So let's tackle that straight out of the gate. So sine 5a is this a, and then, well, we have cosine a cosine 2a minus sine a sine 2a plus 1 minus 2 sine squared a. Sine 3 is sine a cosine 2a plus cosine a sine 2a. And these are obvious, so is cosine a minus 2 sine squared a cosine a. Wait, 1 minus 2 sine squared a, so yeah, that's correct. Minus 2 sine squared a cosine of a is, and then plus 1 minus 2 sine squared a. Sine a minus sine cubic a plus 2 sine a cosine squared a. And then this one is 2 sine a cosine squared a minus 8 sine cubic a cosine squared a plus 1 minus sine squared a, 2 sine squared a is sine a minus sine cubed of a plus what was that? 2 sine a minus 2 sine a 2 sine a cosine squared a. Let's not break that, but instead break these brackets because I am absolutely dreaming. So this one's obvious, it's a 1. Sine a minus sine cubic a plus 2 sine a cosine squared a minus 2 sine cubic a plus 2 sine to the power 5a. Is that really just... That's wrong. Thank God I saw that. That's a 4. And then 4 sine cubic a cosine squared a. And these are straightforward. So 2 sine a minus 2 sine cubed a minus 8 sine cubed a plus 8 sine to the power 5a plus this minus this plus this minus this minus this plus this minus this plus this. Well, that's out of the board. Why is that happening to me? And then obviously counting the terms. Here gives 5 sine a. My iPad is absolutely steaming, but I do not care. That's negative 2, negative 10. That looks weird. That should be a 2. So negative 12. Negative 14. Negative 20. Let's delete these lines. Sine cubed a plus, well, 8, 12, 16. 16 sine to the power 5a. And that's it. That's part A. This is probably worth like 2 to 3 marks, I think. And in part B, this is where it gets interesting. So we could just use the identity we proved in part A. And this is just an order 5 equation with one unknown. So this is not that hard because this is 0 and every term has a sine pi over 5. So we have this, and then with a quartic equation, that's 0 obviously. So sine pi over 5 is 0, or sine squared of pi over 5 is equal to 20 this minus this over 2a. 400 minus 320 is 80, which is 4 roots 5. And 20 plus or minus 4 roots 5 over 32 is just 5 plus or minus root 5 over 8. And this implies sine pi over 5 equals to 0, or root 5 plus root 5 over 2 root 2, which is just root 10. Wait, let me calculate that. Root 10 plus 2 root 5 over 4. Whoops. Handwriting problems. 10 plus 2 root 5 over 4. Or this. Or this. So 5 answers, which is correct. And obviously sine x is an increasing function in the interval 0 and pi over 2. So we have 0 is less than, well, strictly increasing, in fact, is less than sine pi over 5, which is less than sine pi over 4, which is root 2 over 2. We'll use that for clarification purposes. And then we should have these 3 rejected straight out of the window. And then 10 plus 2 root 5. So root 5 is about 2.236. 2.236, more like 2.24 times 2 is 4.48. So 14.48 more or less root 15. Root 15, which gives like 3.87. 3.87 over 4. 3.87 over 4 is about 0.9675, which is bigger than root 2 over 2. So we'll reject this as well. I'm just doing this in my head. So this implies sine pi over 5 is equal to root 10 minus 2 root 5 over 4. So over 4. And then that should be sine pi over 5 right there. And well, we could try to do something about this third right here, because we need the simplest form. And we could try doing this by saying a plus b root 5 is equal to root 10 minus 2 of root 5. Hopefully it works. So obviously squaring both sides, we'd have a squared plus 2ab root 5 plus 5b squared is equal to 10 minus 2 root 5. And then, well, let's just say implies, because this is too simple, which implies we have a squared plus 5b squared equals 10, and 2ab is equal to negative 2. And then let me think about this really quickly, which means we have b is equal to negative 1 over a, and then we could have here a squared plus 5 over a squared is equal to 10, which implies a to the power of 4 minus 10a squared plus 5 equals 0, which means we have a squared equals 10, 100 minus 4, 15 over 2. And again, we have 100 minus 20 equals 80, which is just 4 root 5. We have the same issue. That's pretty idiotic. Let me think about it again. Yes, and then we'd have the same problem. We have the same problem because we'd have to... This is already the simplest form. Again, we have to deal with this. And that's impossible. So we could conclude there exists no integers. There exists no a, b belonging to the integers such that a plus b root 5 is equal to root 10 minus 2 root 5, which implies sine pi over 5 equal to the answer above here that we have 10 minus 2 root 5 over 4 is the simplest form of the exact answer. Let's write that down at the end so it looks better. Answer. And you could do this on Wolfram Alpha if you want, and you still wouldn't get what you want. It is impossible. I forgot what the theorem is to classify the surds into categories of like writing them into this a plus b root c form. I think I forgot what the theorem is. So well, this is the simplest form, and that's the way to prove it, and that's part B, which is the most challenging part, in fact. Part C is more straightforward, so obviously we need to find this integral in part C, and obviously we're going to use part A again. Let's copy that. And then, well, this is just year 7 stuff. And then this term is annoying, so let's go ahead and find what sine cubed A is. And then obviously we have, that's a plus, don't forget that. Cosine squared A, so which is 3 sine A minus 4 sine cubed of A, and which means sine cubed of A is 1 over 4 3 sine A minus sine 3A. Putting this into that, we have 20 over 4 is 5. So we should have this expression. Pretty straightforward stuff. Plus 15 sine A. So we should have 10 sine A minus minus 5 sine 3A. 5 over 16. What am I doing? (16 sine 3A) well, plus 10 over 16, so 5 over 8 sine of a. And this integral is trivial. It's about subbing in the values when it gets hard. So this integral is trivial. That's negative 1 over 80 sine of that's not a sine, come on, that should be a cosine of 5x plus 5 over 48 cosine of 3x minus 5 over 8 sine of, that's not a sine, come on, cosine of x from 0 to pi over 5. And obviously we need to find cosine pi over 5 and cosine 3 pi over 5. So we should just use this. So cosine pi over 5, well, let's copy down sine pi over 5 first, is equal to root 10 minus 2 root 5 over 4, which implies cosine pi over 5 is, well, it should be, so 4 squared is 16, 16 minus this thing squared minus 10 plus 2 root 5 over 4. So we have root 6 plus 2 root 5 over 4 over 4. And that's cosine pi over 5. And the huge question is cosine 3 pi over 5. And that's just, well, you could use this identity if you want to. Well, actually, we don't have cosine 3a yet. Well, you could do the cosine 3a route, or we could do cosine 3 pi over 5 is 1 minus 3 over 5 is 2 over 5. So this is cosine 3 pi over 5 is cosine pi over 2 not really that, it's just cosine pi minus what is that, I can't remember, so 2 pi over 5. So this is just negative cosine 2 pi over 5. And do we have sine 2 pi over 5? And then sine 2 pi over 5. Well, let's do that now. Sine 2 pi over 5 is 2 sine pi over 5 cosine pi over 5. So we should be having 2, 4, 4, which gives 1 over 8. And then sine pi over 5 cosine pi over 5. And well, this looks quite confusing. Let's get it done. That's should be in the third. 60, 20 minus 12, so that should be 8. 4 times 5 is 20, so 40 plus 8 root 5. And then obviously we could have root 8 out of the way. So again we have 5 plus root 5, root 8 over 8. And then root 8 over 8 is 1 over root 8 is 1 over 2 root 2. So it is root 2 over 4. So again we have root 2, 5 plus root 5. Well, rooted, of course, over 4. And then subbing it in, we have 10 plus 2 root 5 over 4. Root it, of course. And for the same reason, this is the simplest form. So cosine 3 pi over 5 is equal to, is equal to negative root of 16 minus 10 minus 2 root 5 over 4, which means this is negative root 6 minus 2 root 5 over 4. And now we have all the values required. So we have 0 to the power over 5 sine to the power over 5 dx is equal to, that's a huge chunk. So negative 1 over cosine pi is 0. Cosine pi is negative 1, not 0. That sounds stupid, not gonna lie. So so we have 1 over 80 plus 5 over 48 cosine 3 pi over 5. So 5 over 48. So 5 over 48 times this is 48 times 4 should be 192. So we have 5 root 6 minus 2 root 5 over 192 plus, is that plus or minus? Can't remember. That's 5 over 8 cosine pi over 5. So cosine pi over 5 is this baby. So minus 5 over 32. Well, root that over 32. And then we have the zeros. Cosine 0 is 1. So we have plus 1 over 80 minus 5 over 48 and then plus 5 over 8. And this is, well, let's just use the calculator. I give up. So we have 131 over 240 minus this and then minus this. So let's just have two certs because they look extremely different. But then is, so we have 5 over 192. Let's group the certs. Root 6 minus 2 root 5 plus plus 6 times root 6 plus 2 root 5. And I think that's probably it for the question.